There is a gambling proverb that the house always wins. And it's not that the casino or house is luckier than the player. It's that for every game that the casino puts on the floor before they do, they make sure that they have a statistical advantage. And the formula or equation that casinos use to verify they have a statistical advantage is known as the expected value formula. So Investopedia has the formula written as follows, where in the case of, say, rolling a die, the question would be, what would be the mean or median value as this die were rolled into an infinite number of times? So one would know that there's a 1/6 chance that the die would land on any one of the sides. So 1/6 chance of it landing on a 1, 1/6 chance of landing on a 2. So it's 1/6 divided by times 1, 1/6 times 2, all the way up to 1/6 times 6. If you were to take all these numbers together and add them up, the median or mean value is 3.5, which tells you that if one were to roll a die an infinite number of times, the mean and median value would be 3.5. And in order to apply this formula to gambling, one would have to incorporate not only the probabilities, but also the amounts. So it could kind of be written as follows. So the financial expected value equation could be written, at least for a binary outcome, probability of a win times the amount per win minus the cost. And you take that and subtract probability of a loss times amount per loss, and you have to add the cost. Typically with casinos, they don't charge costs. They make their money by setting the odds. So if a casino were to have a game, suppose a game involving the rolling of a die, and they could set the rules so that the player would bet on a 6-sided die. The player would roll the die, and if the die lands with the player's number face up, then the player gets a payout of X to 1, and X are the odds. So in order to determine what to set the odds at, the casino would use the EV equation in order to make sure that the game is profitable for the casino. So first they would define all outcomes. So the die can land on 1 through 6. The probability of the die landing on any given number is 16.7, and therefore the probability of the player losing is 83.3. And you divide 83.3% divided by 16.7, and you know the break even is 5 to 1. The casino could then use the EV equation in order to determine the odds, or what odds they want to set the game at. So they know that the percent chance of the player winning is 16.7%, and the percent chance of losing is 83.3%. They know that the player will lose 1 or 100% of their money when they lose, and then the payout amount or the odds is what they would adjust. So if they were to set the odds at 1-to-1 payout, then the player could expect to lose 66.7% of their money over time. If they were to set the odds at 2-to-1, the player could expect to lose 50% of their money, 3-to-1, 33%. And then you can see at 5-to-1, the game is even. So as a casino, they would set the odds at less than 5-to-1 in order so that the game is profitable for the casino. And if a player were to enter a casino and see this game, they would need the odds to be greater than 5-to-1 in order to make money. So if one were to enter a casino with the intention of making money, before doing so, one would want to know what game they're going to play and how they're going to play it, and they would use the EV equation to help their decision making. And similarly, before one enters the financial markets, one would want to know what they're going to play and how they're going to play it. For instance, if they decide to trade stocks, are they going to day trade, swing trade, buy and hold, long, short, use options? And they would also use the EV equation in order to help drive their decisions. As an example as to how one could apply the EV equation to stocks, so this is the SPY, which is S&P 500 ETF. This is the current price. This is the October 2022 lows, and this is the January 2022 highs. So these are the price points. 452.49 is the current price as of July 27th, 2023, Thursday. This is the October low of 348.11, and this is the high of January high 2022, 479.98. Suppose one were to consider getting short at the current price of 452.49 and hope for the price to go below to 348 and put their stop just above the high at 480. So it would look like this. Their current price 452.49. Their limit price would be 348. So if the price gets down to 348, their trade wins getting short. That would be a limit percentage of 23.1% or a win percent of 23.1%. Their stop would be 480, which is 6.1% losing percentage, percent loss. So as far as the financial expected value equation, you know the amount per win, and let's assume there's no cost, and you know the amount per loss. So the amount per win would be 23.1. Amount per loss 6.1, and then one would then have to determine the probability of win versus probability of loss. And the two things that one would use in order to determine the probability of win and probability of loss would be either mathematical reasoning and intuition, or empiricism, or kind of a combination of the both. As an example of mathematical reasoning and intuition, in the case of the six-sided die, you don't have to roll the die an infinite number of times in order to know that the chances of any given number appearing is 1 out of 6. And then as far as empiricism is concerned, one would have to collect data of similar setups and determine percentages based on the past results. So for instance, say this similar setup was said to have occurred maybe 100 times in the past, and 70% of the time the price went up and onto all-time highs, and maybe 30% of the time the price came down and took out this low. So as far as this equation is concerned, you would use 70% chance of a loss, of it going up and stopping you out, and 30% chance of a win, where it would come down and limit you out for a win. And going back to the SPY potential short trade example, suppose that one were to come to the conclusion, after using mathematical reasoning and intuition and empiricism, one were to come to the conclusion that the limit probability or probability of a 1 is about 10%, where the price would go on and take out those lows, and the probability of a loss or a stop where is about 25%, where the price would go higher and take out the highs, and maybe a break-even probability of 65%, where maybe the price stayed in between those 2 points and you eventually got out, hopefully for a break-even. You now one knows the win probability and the loss probability. So going back to the formula, you know the probability of the win and the amount per win, the probability of the loss and the amount per loss. So the probability of the win is 10%, and the amount per win is 23.1%, and the probability of a loss is 25%, and the amount per loss is 6.1%, and this results in a positive EV of 0.8%. So it would be considered as a possible trade because it's positive, but one would then probably want to go on and compare it to other potential trades.